This is class 25 of my arithmetic course. Today we're going to be learning ratios and rates. If you haven't done the homework from the last class, do that homework completely and correctly before watching this video. We're going to start by learning ratios. A ratio is a relation between two numbers. To demonstrate, let's look at this example. Don jumped 4 feet and Tim jumped 3 feet. So let's say that that's one jump each. If each person jumps twice, then Don will jump 8 feet and Tim will jump 6 feet. And if each person jumps 3 times, Don will jump 12 feet and Tim will jump 9 feet. And if each person jumps 4 times, Don will jump 16 feet and Tim will jump 12 feet, and so on and so forth. So when we say that a ratio is a relation between two numbers, that's what we mean. Each pair of numbers is a ratio, and they maintain the same relation. Now notice that we multiply these two numbers by the same number to get 8 and 6, and we multiplied those two numbers by 3 to get 12 and 9, and we multiplied both those numbers by 4 to get 16 and 12. So you always multiply the two numbers in a ratio, in this case 4 and 3, by the same number. That was also true of fractions. In fact, ratios can actually be written as fractions, as you can see here, 4 over 3. So ratios work much the same way as fractions do, in the same way that you can multiply the numerator and the denominator of a fraction by the same number. You can multiply both the numbers in a ratio by the same number. And you can divide if you want to make the numbers smaller. So there are 3 ways to write a ratio. You can write it, like I said, as a fraction, or you can write it with a colon in between. As you see here, a colon is 2 dots written vertically. Or you can write it with the word 2 in between. So we say 4 to 3, 4 to 3, 4 to 3. You say it the same way, regardless of which way you write it. Now it's important to understand that the ratio 4 to 3 is not the same as the ratio 3 to 4. If you change the numbers around, the ratio is not considered to be equivalent. So that's an important point. So they're not equivalent. In the same way that 4/3 is not the same thing as 3/4. Ratios are not equivalent if you mix the numbers around. So if you don't understand what this means, that's okay. Just remember that you can multiply both numbers in a ratio by the same number, or you can divide both numbers in a ratio by the same number. So to demonstrate that, we'll do some practice problems later on, but first let's just get some practice on how to write the 3 forms of a ratio. Number 1, I have $1 and you have $6. Write ratios of these two numbers in 6 different ways. So we can write as a fraction with a colon in between and with the word 2 in between. But we can also write a different ratio. We can write 6 over 1. So you can write the 6 first in the 3 different ways also. So that's 6 different ways to write ratios. But just keep in mind that these ratios are not equivalent to these ratios. All right. Now, why don't you try number 2, and when you come back, we'll do it together. All right, we're back. So we can write it as 20 over 11. We can write it with a colon. We can write it with the word 2, or we can switch the numbers. And write the same 3 forms. So if you got those as your answers, good job. Let's try one more of those before we go on to some more difficult ratio problems. Try number 3, and when you come back, we'll do it together. All right, we're back. You can write 300 over 107 as a fraction. You can write it with a colon in between. You can write it with the word 2 in between. And of course you can switch the numbers around. So if you got the right answer there, good job. That's 6 different ways to form a ratio with those two numbers. Well, actually, it's really only 2 different ways, but we're writing the 2 different ways in three forms each. Okay, so let's go on to some more problems here. Now we're going to learn how to reduce a ratio to lowest terms. So in the same way that you reduced fractions to lowest terms, we're going to reduce ratios to lowest terms. It works the same way. So remember, if you had something like 56 over 72, you just divide both sides of that fraction by 8 and you get 7 over 9. Well, ratios work the same way. If you write the ratio as 56 with a colon 72, you just divide both sides by 9 or by 8 and you get 7 to 9. So that's what we're going to do for number 4. There were 8 gumballs in one bowl and 6 gumballs in another bowl. Write these two numbers as a ratio in lowest terms using a colon. So if we write the numbers they gave us, it's 8 to 6. But if we divide both those numbers by 2, we get 4 to 3, and that ratio is in lowest terms. But we can't go on yet. It says then, write the simplified ratio in 2 other ways. So we wrote it using a colon, but we can also write it as a fraction, and we can write it as we can write it with the word 2 in between. Now you could also write 3 to 4. That would be fine, and then your answer would look like this, because they didn't specify which number to say first. All right, let's go on to number 5. Why don't you try number 5, and when you come back, we'll do it together. All right, we're back. So we have 63 and 49, or you could write 49 and 63 because it doesn't specify which type of ratio it wants. Divide both numbers by 7, and you get 9 to 7. That's the ratio in simplified form, lowest terms. But then it says, write this simplified ratio in 2 other ways. So we can write 9 over 7, and we can write the ratio with the word 2 in between. But again, if you write the 7 first, that's okay also, because it didn't specify which way to write the numbers. So problems 6 through 17 are just writing ratios in lowest terms. So let's do some together. Number 6, if we divide both numbers by 2, we get 4 and 5. That's the ratio in lowest terms. Number 7, if we divide both numbers by 4, then we get 5 to 4. That's the ratio in lowest terms. And for number 8, if we divide both numbers by 3, we get 2 over 5. That's the ratio in lowest terms. So why don't you try number 9, and when you come back, we'll do it together. All right, we're back. We can divide both numbers. I know my multiplication facts, so I know that 5 goes into both those numbers. So 45 divided by 5 is 9, and 25 divided by 5 is 5. I divided both numbers by the same number. I divided both of them by 5. All right, if you got the right answer, good job. Try number 10, and when you come back, we'll do it together. All right, we're back. Divide both numbers by 2, and you get 5 and 12. So if you got the right answer, good job. Let's go on to the next one. Well, why don't you try this one on your own, and when you come back, we'll do it together. All right, we're back. divide both numbers by 7 and you get 4 over 3. So if you got the right answer, good job. Again, we're just reducing the ratios to lowest terms. All right, so number 12, the difference for number 12 is we can divide both of the numbers by one of the numbers that's actually represented in the ratio, because 9 goes into both those numbers. If we divide 18 by 9, we get 2. If we divide 9 by 9, we get 1. So the ratio in simplest form is 2 to 1. For number 13, we can divide both numbers by 4 and we get 1 to 1. A 1-to-1 ratio just means that the two numbers are going to be obviously the same. For example, if I have 5 cents, well, in this case, it would be 4 cents. Let's say I have 5 cents in my pocket and I have 4 cents in my pocket and you have 4 cents in your pocket. We have the same amount of change, so the ratio is 1 to 1. Number 14, divide both numbers by 8 and you get 1 over 7. So that's the ratio in lowest terms. Now you try number 15, and when you come back, we'll do it together. All right, so number 15, we're going to divide both numbers by 26, and we get 1 to 1. 26 divided by 26 is 1. 26 divided by 26 is 1. If you got that one right, good job. Try number 16, and when you come back, we'll do it together. All right, we're back. 10 goes into both those numbers, so divide 10 by 10, you get 1. Divide 20 by 10, and you get 2. All right, number 17, try that one, and when you come back, we'll do it together. All right, we're back. Divide both numbers by 6. 36 divided by 6 is 6, and 6 divided by 6 is 1. That's the ratio in lowest terms. So again, all we did with those problems was we just took the ratios and reduced them to lowest terms. That was all these problems. That's just the smallest whole numbers that we can get without going into fractions. You are allowed to have fractions and ratios, but it's traditional to have the lowest whole numbers possible. In the same way that you reduce fractions, you want the lowest whole numbers possible. You don't want fractions inside fractions, or that would be called a complex fraction. You'll learn how to simplify those when you take beginning algebra. That's not the next class, but the class after the next class. All right, now we're going to go into the reverse direction. Number 18, the ratio of Mark's pocket change. And when I say reverse direction, I mean instead of dividing both the numbers, we're going to be multiplying both the numbers. The ratio of Mark's pocket change to Dylan's pocket change is 2 to 3. If their combined pocket change is 30 cents, how much pocket change does Mark have? So when it says combined pocket change, it says take Mark's pocket change and then add it to Dylan's pocket change, and they both have a total of 30 cents. That's what it means when it says their combined pocket change. So here's how we do this. What we do is we write our ratio, and then we find a bunch of equivalent ratios with bigger numbers. Well, first of all, before we even do that, let's just assume that Mark has 2 cents and Dylan has 3 cents. That would maintain the proper ratio, but the problem is when you add those two numbers up, you get 5 cents. You don't get 30 cents. We need 30 cents. So what we're going to do is we're going to find some equivalent ratios with bigger numbers. See, this is the ratio. Whenever you're given a ratio, like I said, it's almost always written in lowest terms. So this is the ratio in lowest terms, but that doesn't represent the actual number of cents that each person has. This person doesn't have only 2 cents, and this person doesn't only have 3 cents, because again, if you add those up, you get 5 cents. We know they both have 30 cents. Again, the ratio only tells you the relation between the two numbers. It doesn't necessarily give you the exact numbers. So what we're going to do is we're going to find equivalent ratios. So multiply both these numbers by 2, and you get 4 to 6. Now if you add those numbers up, you get 10 cents. Well, that's closer to 30, but still pretty far away. So let's multiply 2 and 3 by 3, and we get 6 to 9. Now add 6 and 9 up, and you get 15 cents. We're getting closer, but we're still pretty far away. So let's multiply 2 and 3 by 4, and you get 8 to 12. Add those two numbers up. And again, this situation says Mark has 4 cents and Dylan has 6 cents. This situation, Mark has 6 cents and Dylan has 9 cents, and so on and so forth. So now if we add these two numbers up, Mark has 8 cents and Dylan has 12 cents. Add them up and you get 20 cents. So we still need to use bigger numbers. And I know what you're thinking. Can't we start on this number and multiply this number by 2? Yes, you can. But then you would go straight to this, or excuse me, this ratio. You're thinking, can we multiply this ratio by 2 to get to 8 to 12? But the problem with that is you would skip 6 to 9. So you always want to start with the original ratio in lowest terms. So multiply 2 and 3 by 5 and you get 10 to 15. Add those two up and you get 25 cents. We're almost there. Multiply 2 and 3 by 6 and you get 12 to 18. Add those two numbers up and you get 30. So these numbers, this equivalent ratio, actually represents the actual amount of money in each person's pocket. So one of the person's pocket change is 12 cents, and the other person has 18 cents. Now, there's an extremely important thing to note, and that is that notice that Mark, his name comes first in the ratio. So it says Mark's pocket change to Dylan's pocket change. What that means is that the first number in the ratio represents the first person or thing that was mentioned. So 2 represents Mark's pocket change, and 3 represents Dylan's pocket change. So this question is asking, how much pocket change does Mark have? So because Mark was mentioned first, that means the first number, in this case 12, is the answer. So Mark has 12 cents. That's an extremely important point. If you get it backwards, if you put the numbers in the reverse order, then you're gonna get the wrong answer. If you wrote 18 cents, that would be Dylan's pocket change, and that's not what they're asking. They're asking for Mark's pocket change. Let's do one more of these together, and then you can try a couple on your own. The ratio of the areas of two different rectangles is 5 square meters to 7 square meters. If the total area of the two rectangles is 60 square meters, what are the areas of each rectangle? So the ratio that they gave us in lowest terms is 5 to 7. Again, when ratios are stated, they're almost always stated in lowest terms. But these numbers don't represent the actual areas. These numbers just represent the relation between the areas in lowest terms. So we don't want lowest terms, because if you add these two numbers together, 5 plus 7, that's 12. That's a long ways away from 60. So what we're going to do is we're going to just do the same thing we did up here. We're just going to start multiplying. But in this case, I want to get there a little faster. So let's try multiplying both numbers by 10. Then we get 50 and 70. Add those two numbers up and you get 120. Well, that was way too big. So let's go back to 5 and 7 and multiply both numbers by 4. Then you get 20 and 28. Add 20 and 28 up and you get 48. So that's a little bit too small. And if you're a little frustrated about adding those numbers, you can just line them up vertically, as we learned in class number 3 or 4, or whatever that was. 8 plus 0 is 8. 2 plus 2 is 4. 48. Let's try multiplying both 5 and 7. Whoops. Multiply both 5 and 7 by 5. Then you get 25 and 35. Add those two numbers up. You can line them up vertically if you want, or you can just do it in your head. 5 plus 5 is 10. Carry the 1. 1 plus 2 is 3, plus 3 is 6, and you can see we got the right answer, 60. All right, so now we have the numbers that actually represent the areas of the two rectangles. These two numbers represented the ratio of the two areas in lowest terms. But if we want the actual areas of the rectangle, we need these numbers. So they want to know what the areas of both rectangles are. So one rectangle is 25 square meters and the other is 35 square meters, and that's the answer. So why don't you try number 20, and when you come back, we'll do it together. All right, we're back. The ratio that they give us is 5 to 2, and we want those two numbers to add up to 63, so I'm going to try multiplying both numbers by 4, and we get 20 and 8. Add those up, you get 28. That's nowhere near. So we need, let's multiply both numbers by 7, and then you get 35 and 14. Add those numbers up, and you get 49. So let's try multiplying 5 and 2 let's try 9. 9 times 5 is 45. 9 times 2 is 18. Add those two numbers up and you get 63. So those are the two numbers that we want. And it wants to know how many points did Alice score. So here's the big question. Is Alice 45 points or is Alice 18 points? Well, it says Jake's name first in the ratio. Jake scored the points that Jake scored to the points Alice scored. So Jake is the first number. All right, and Alice is the second number. So it wants to know how many points Alice scored. So that would be 18. So if you got 18 points, good job. And just be aware that you don't have to write all of these out. I'm just doing that to help you see the process here. You can jump forward and try to find the answer as quickly as possible. All right. Why don't you try number 21, and when you're done, we'll come back and do it together. All right, we're back. The ratio they give us is 4 to 9. And we want the numbers to add up to 39, so let's try multiplying both those numbers by 5, and you get 20 and 45. Add those up and you get 65. Whoops, I was way off there. Let's try multiplying both numbers by 3, and you get 12 to 27. Add those two up, and you get 39. Again, if you're not comfortable doing that in your head, you can just line them up vertically. 7 plus 2 is 9. 2 plus 1 is 3. All right, so it wants to know how many gallons of gasoline does Leo's car have. So we have to figure out which one of these is Leo. Is it 12 or is it 27? Well, it says the number of gallons of gasoline in Chelsea's car. It says that first. Then it says number of gallons in Leo's car. So the second number represents Leo's car. So we want the number of gallons in Leo's car, so 27 gallons. If you got the right answer, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. All right. So now we're going to do some more ratio problems. But the difference between these ratio problems is we're going to get our numbers from a table. Now, tables and graphs and charts are really popular these days in school. They're on college entrance exams and any kind of entrance exam pretty much. High school entrance exams, middle school entrance exams. And you'll see these all over the place. So let's do a practice problem where you have to get your information from a table. These problems are really easy. Again, the only difference is you're using a table. So let's read the situation. The table below lists the costs of Amanda's school supplies. Answer the following questions in the table. Answer the questions that follow the table. So number 22, what is the ratio of the cost of dividers to the cost of paper? So dividers is 2 and paper is 4. So that's the ratio. But remember, it's traditional to write the ratio in lowest terms. And in this class, I always want you to write the ratio in lowest terms. So we're going to divide both numbers by 2, and we get 1 to 2. So that's the answer. All right, number 23. Why don't you try number 23, and when you're done, we'll come back and do it together. All right, we're back. The ratio of the cost of pencils, which is $3, to the cost of a 3-hole punch, which is $8. That's the answer. Now, we don't have to reduce that to lowest terms because it already is in lowest terms. Now, number 24. 24 is going to be a little bit different. There are some ratios where you have one number that's a simple quantity, and you'll have another number that represents the result of certain calculations that you have to do. So 24 will give you an example of that. Find the ratio of the cost of binders to the total cost of all Amanda's school supplies. So first we write the ratio. First we write the cost of binders, which is 16. But the next number is going to represent the sum of all costs for Amanda's school supplies. So you have to add them up. 3 plus 7. 3 plus 4 is 7. Plus 16 is 23. Plus 2 is 25. Plus 8 is 33. So the next number is the total cost of all Amanda's school supplies, and we can't reduce that. So the first number was a very simple quantity, but the second number we had to get from calculations that we had to do. So number 25 is somewhat like 24, but in 25 it asks to find the ratio of the differences. So remember, sum means addition, but difference means subtraction. So see if you can do number 25, and when you come back, we'll do it together. All right, we're back. What is the ratio of the difference in cost between pencils and dividers? So we want pencils and dividers, pencils minus dividers, colon, and difference in cost between binders and a 3-hole punch. Binders and a 3-hole punch. So that's the ratio that we're looking for. Up here we have the ratio of binders, cost of binders to the total cost, which you could write, I guess we could write as S for sum. But down here we want pencils minus dividers to binders minus 3-hole punch. So we just go up here and we say binders, or excuse me, pencils. Pencils is $3. Dividers is $2. Binder is 16, and 3-hole punch is 8. So then we'll write the final 3 minus 2 is 1, and 16 minus 8 is 8. So that's the ratio of the difference in cost between pencils and dividers to the difference in cost between binders and a 3-hole punch. So as you can see, this math is extremely easy, ridiculously easy. But sometimes the numbers in a ratio are the result of calculations that you have to perform. Let me just check to see if that's correct. I didn't make any dumb mistakes. Now there is one thing that I didn't mention that's extremely important. Notice it says, what is the ratio of the difference in cost between pencils and dividers? Pencils were mentioned first, so you have to subtract dividers from pencils. See, pencils have to come first, so just be aware of that. And in the second part, binder was mentioned first, so the binder comes first, then you subtract 3-hole punch from binders. If you do it the opposite direction, you're going to get negative numbers. So that's important to remember. All right, so why don't you try number 26, and when you come back, we'll do it together. All right, we're back. So we want, whoops, I just realized that I took the table away from you. I'm sorry. Now you have the table. Now attempt the problem, and when you come back, we'll do it together. All right, we're back. So find the ratio of the sum of the cost of pencils and paper. So pencils and paper, and they're both P's, but oh well. And to the sum of the cost of binders and dividers. So pencils and paper, pencils plus binders. First of all, pencils is 3, paper is 4, binders is 16, and dividers is 2. So that means 7 to 18. Let me just double check that. It looks correct, and we cannot reduce that. So if you got the right answer, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. All right, so on to 27. These problems are pretty much the exact same problems that we just did. The only difference is we don't have a table. So let's do one of these together. Jason scored 7 points, Linda scored 5 points, and Abby scored 8 points. What is the ratio of the number of points that Abby scored to the total number of points that all 3 people scored? So we know the ratio, we know the number of points that Abby scored is 8. So what is the ratio of the number of points that Abby scored? We got that part, is 8. Then it says to the total number of points that all 3 people scored. So that's going to go here. And we just add all the numbers up. 7 plus 5 is 12. 12 plus 8 is 20. So that number will be 20. Let me get rid of all this highlighter. So 8 to 20. But that ratio is not in lowest terms. So we have to divide both numbers by 4. And we get 2 to 5. All right, so why don't you try, actually let's do 28 together. Bobby's height increased from 60 inches to 65 inches. What is the ratio? What is the ratio of his increase in height to his new height? So his new height, that's the easy part. His new height comes second in the sentence, so we have to write the new height, which is 65. But then the first number is going to be his increase in height. So if he was 60 inches and now he's 65 inches, what is his increase? Well, obviously it's just 65 minus 60. So it would be 5 to 65. I simplified these numbers to make 5. But that's not going to be the answer because 5 to 65, that can be reduced. But 65 is kind of a big number though. So we might have to use our long division methods to figure out what the reduced form of this ratio is, the ratio in lowest terms. So 5 goes into both those, so divide both by 5. 5 divided by 5 is 1, and 65 divided by 5, we'll do that over here. 5 goes into 6 one time. 5 times 1 is 5. 6 minus 5 is 1. Bring down the 5. 5 goes into 15 3 times. 3 times 5 is 15. Remainder 0. 15 minus 15 is 0. So again, remember when you're doing division, there's 3 cycles. The first cycle is see which number goes up here. The second cycle is multiply the 2 numbers and put it here. The third, I think I'm saying cycles, I mean steps. The first step is figure out what number goes here. The second step is multiply these 2 numbers and put it here. And the third step is subtract to get 1, and then you start the whole cycle over again. So 65 divided by 5 is 13. So the answer is 1 to 13. Now you try number 29, and when you come back, we'll do it together. All right, we're back. So Alan found 3 seashells while Gordon found 14 seashells. What is the ratio of the total number of seashells that they both found to the number of seashells Alan found? So the total number is 14 plus 3, which is 17. And the second number is the number of seashells Alan found, which is 3. So if you got 17 to 3, good job. Again, we're looking for the ratio of the total number of seashells that they both found to the number of seashells Alan found. On to number 32. Here's some more ratio problems. There are hammers and nails in a toolbox. The ratio of the number of hammers to the total number of hammers and nails is 3 to 10. What is the ratio of hammers to nails? Now, before we do this problem, I want to mention something. Technically, ratios are supposed to have the same units. What I mean by this is all the previous problems that we did, the two numbers always had the same number of units, or the same type of units. For example, Don and Tim, they both jumped a certain number of feet. We had feet and feet. They were the same units. And in the gumball problem, we had 8 gumballs and 6 gumballs. Same units, gumballs and gumballs. And the problem that we did just a moment ago, we had dollars and dollars. So as you can see, we always have the same units. Ratios are supposed to have the same units. But I just want you to be aware that many times teachers write ratios with different units because they're either not aware that ratios are supposed to have the same units, or they're aware but they just don't care. So people who write, teachers, people who write tests, all kinds of people, they write ratios with different units. So in this class, we're going to do the same. We're going to write ratios with different units, just to let you know that you can see ratios with different units in school. So this problem is different because we have number of hammers and number of nails. Those are different units. But to be honest with you, most high school students and middle school students and college students, and like I said, even teachers are unaware that ratios are supposed to have the same units, so it's not really that important for you to remember. And most people don't know and don't care. But I just want you to be aware that technically ratios are supposed to have the same units. The concept we're going to go over next, rates. Rates are different than ratios. Rates, they can have different units, but ratios are supposed to have the same units. But this is an example of a problem where the ratio has different units. So we have the ratio of the number of hammers to the total number of hammers and nails. And it wants to know what is the ratio of hammers to nails. So it wants to know the ratio of the number of hammers to the number of nails, H to N. We don't have that ratio. The ratio that we have, let me move this over. The ratio that we have is hammers to the sum of hammers and nails. That's 3 to 10. We want this ratio here. So it turns out this is really easy to figure out, because if this number represents hammers and nails, and this just represents hammers, then all you have to do is subtract 3 from 10 to get 7. So the number of nails is 7. And hammers, we already knew, was 3. Again, this number we already knew. We were just looking for this number. All right. We're going to make sure we did it in the right order. It wants hammers to nails, so we did it in the right order. So 3 to 7 is the ratio of hammers to nails. Let's do one more of those problems, and you can do some on your own. The ratio of the number of foxes to the difference between the number of foxes and the number of coyotes is 4 to 3. What is the ratio of the number of coyotes to the number of foxes? So we have the number of foxes, the ratio of the number of foxes to the difference between the number of foxes and coyotes. They tell us that is 4 to 3. What we want is the ratio of the number of coyotes to the number of foxes. So notice I switched the animals around. Here I said foxes first. Here I said coyotes first. So just be aware of that. I'm going to try to trick you like that. We want coyotes first, then foxes. So this problem works in the same way that the previous problem worked. If hammers plus nails equals 10, and we know we have 3 hammers, then you can just subtract. Now again, these don't represent the actual numbers, but you can subtract or add and get the answer you're looking for just by coincidence. So you have 4 foxes, and you subtract the number of coyotes, and you get 3. So if you have 4 foxes and you subtract the number of coyotes and you get 3, obviously there's 1 coyote. So the ratio is 1 to 4. All right, so the ratio of the number of coyotes to number of foxes is 1 to 4. So why don't you try number 34, and when you come back, we'll do it together. All right, we're back. We have the ratio of the total number of parakeets and finches. So parakeets plus finches is 8. We have the total number of parakeets and finches to the number of parakeets. And the number of parakeets is 5. And they want to know what is the ratio of the number of finches to the number of parakeets. So we know that parakeets are 5, and the total number of parakeets and finches is 8, so we just take 8 minus 5 is 3. And that gives us the number that we're using for the relation for finches. Total number of parakeets is 5. And that's our answer. If you got 3 to 5, good job. Just making sure I did that right. It looks good. Why don't you try number 35? When you come back, we'll do it together. All right, we're back. The ratio of the difference between the number of puppies and the number of kittens to the number of kittens is 4 to 7. Now, it says puppies first, so we have to say puppies minus kittens to the number of kittens. So P minus K is 4, and K is 7. So if you take the number of puppies and you subtract the number of kittens, you get 4. So we know there are 7 kittens, so if you take the number of puppies and minus 7 and you get 4, that means there are 11 puppies. Now the reason we wrote 7 first is because it wants to know the ratio of the number of kittens first, then puppies. So puppies comes second, kittens comes first. So if you got the right answer, good job. All right, on to number 36. Now we're going to do ratios relating more than 2 numbers. 6 red posters to 9 blue posters to 24 green posters. When you have more than 2 numbers, the ratios work in the same way. You can divide all the numbers by the same number, or you can multiply all the numbers by the same number. So we can divide all, if you want to reduce these, reduce this ratio, just divide all the numbers by 3 and you get, so well, first let's write the ratio. So you need 2 colons on this. Divide all numbers by 3 and you get 2 to 3 to 8. So we reduce the ratio to lowest terms. Why don't you try number 37, and when you come back, we'll do it together. All right, we're back. Let's go ahead and write the ratio. Divide all numbers by 2. and you get 5 to 2 to 6. So if you got the right answer, good job. If you didn't, just go back and figure out what you did wrong. On to number 38. 54 hotels to 81 homes to 45 apartments. Go ahead and reduce that ratio to lowest terms. All right, if we divide all those numbers by 6, we get 9. Actually, 6 doesn't go into all those. Divide all those numbers by 9, and you get 6 to 9 to 5. So if you got the right answer, good job. All right, so let's go to some practice problems, or some word problems. We've already been doing practice problems. We're going to go to some word problems involving ratios with 3 numbers. If the ratio of Zane's number of books to Lisa's number of books to Ellie's number of books is 5 to 3 to 11, and the sum of all their books is 57, how many books does each person have? So we've already done these types of problems. The only difference is now we have 3 numbers. So this is when you go in the reverse direction. So let's write the ratio, 5 to 3 to 11. And let's assume that those represent the actual numbers. If we add those numbers up, 5 plus 3 plus 11, we get 19, but that's not enough. So those numbers don't represent the actual number of books that each person has. So we're going to have to multiply all those numbers by 2. We'll try 2 first. Then we get 10, 6, and 22. Then you add those numbers up, and you get 38. So that's not big enough. And we just keep going and going. So why don't you keep going with this problem, and when you're done, we'll come back and do it together. All right, we're back. If you multiply 5, 3, and 11 by, let's try 4, you get 20 to 12 to 44. Add those up, that would be, and again, if you're not comfortable doing that in your head, then you can do it vertically. We get 76. Whoops, that was too big. So let's try multiplying all those numbers by 3, and you get 15 to 9 to 33. And if you add those up, you get 20. You get 42, 52, 57. So that's right. So these numbers represent, these all add up to 57. And now what is it asking? How many books does each person have? So we don't have time to write out the actual names, but we'll just say Zane 15, Lisa 9, and Ellie is 33. We should write that we're counting books, though. All right. So if you got the right answer, good job. Number 40, the ratio of Edward's number of baseball cards to Stephen's number of baseball cards to Casey's number of baseball cards is 7 to 10 to 4. If the combined number of all their cards is 105, how many cards does each person have? So why don't you attempt this problem, and when you come back, we'll do it together. All right, we're back. So let's write down the ratio that they gave us, and let's assume that those numbers represent the actual numbers of cards. If we add those numbers up, then we get 21. So as you can see, that's not big enough. We need 105. So I'm going to multiply all those numbers by 5, and we get 35, 50, and 20. If we add those numbers up, we get 85, 95, 100. I guess I got lucky because those are the right numbers. Now again, if you don't feel comfortable doing that in your head, then you can do it vertically. Whoops, that should be 10. You can do it vertically like so. All right, so how many cards does each person have? Edward has 35 cards. Stephen has 50 cards. And Casey has 20 cards. So if you got the right answer, good job. If you didn't, just go back and figure out what you did wrong. So that was your introduction to ratios. Again, a ratio is just a relation between two numbers, and you treat the numbers in a ratio like you would treat the numbers in a fraction. You just multiply. You can multiply both numbers by the same number, or you can divide both numbers by the same number, and the ratio that you get will be equivalent to the original ratio. If you want to write the ratio in lowest terms, you just divide the numbers until you get the lowest whole numbers possible. The units in a ratio are supposed to be the same, even though people violate that rule all the time. And you can have a ratio with more than two numbers. You can have a ratio with three numbers. And you can have problems where you have a table with all the information in the table. And you can have problems where you have to go in the reverse direction. You have to multiply both numbers. So there's a lot of different problems that you can get with ratios. So now, also you can have ratios where one quantity represents a set of calculations. So now let's go to rates. And rates are the last thing that we're going to do today. A rate is much like a ratio, but there are two differences. The first difference we already discussed. In rates, the numbers have different units, whereas in ratios, the numbers are supposed to have the same units. So, for example, a rate would be 12 miles in 8 hours. See how the units are different? So that's a rate when the units are different. It's a relation between two numbers where the units are different. So rates are just like ratios in the sense that they're relations between two numbers, but the difference is the units will always be different in rates. That's the first difference. The second difference is that rates are always written as fractions, whereas ratios are not always written as fractions. Sometimes you see them with a colon or with the word 2 in between. Ratios, you always write them as, well, you can write them obviously as a sentence as you see here, but otherwise you would see them as fractions. So to start off, we're going to learn how to reduce rates to lowest terms, and you really already know how to do this. Rates, you can just consider them to be fractions. The same rules apply. So you can multiply both sides of the fraction by the same number, or you can divide both sides of the fraction by the same number. It's the fundamental principle of fractions that we learned in previous classes. So to write these rates in lowest terms, let's start with 41. We're going to divide both numbers by 4. 12 divided by 4 is 3. And 8 divided by 4 is 2. So that's the rate in lowest terms. Let's do another one. $40 for 25 pies. Again, this is a rate because you have different units. You have dollars, and you have pies. So if we divide both those numbers by 5, we get $8 for 5 pies. That's the rate in lowest terms. So why don't you try number 43, and when you come back, we'll do it together. All right, we're back. You can divide both those numbers by 2, and you get 2 quarters. For every 5 dimes. That's the rate in lowest terms. Try number 44, and when you come back, we'll do it together. All right, we're back. You can divide both those numbers by 2. 18 divided by 2 is 9. And 8 divided by 2 is 4. So if you got the right answer, good job. Okay, now we're going on to something different. Now we're going on to a special type of rate. These rates up here were in lowest terms, but they're not unit rates. We had 3 miles in 2 hours. We had $8 for 5 pies, 2 quarters for 5 dimes, 9 cars for every 4 trucks, and we had 12 miles in 8 hours and $40 for 25 pies. These were rates. In this case, we had some random rate, and then we had the rate in lowest terms, but none of these rates, none of them are unit rates. In order for something to be called a unit rate, the second number has to be 1. So the second number in this example, for example, was 5. So that might have been the rate in lowest terms, but it was not a unit rate. In the next problems that we're going to do, we have to find unit rates. So the second number has to be 2. Or excuse me, the second number has to be 1. All these numbers have to be 1 in order to change those to unit rates. So that's what we're going to do now. On number 47, we're going to have to find the unit rate. These are 2-step problems. We're going to have to find the unit rate first, and then we're going to use the unit rate to solve the problem. The reason that unit rates are important is because they make things easy for us when it comes to solving problems. So let's read the problem. If there are 60 bunnies for every 6 kittens, how many bunnies are present for every 8 kittens? So this problem is not easy to solve with the numbers that they're giving us. So we first have to find the unit rate, then we'll use that unit rate to find how many bunnies for every 8 kittens. So here's what we do. To find the unit rate, all we have to do is divide the 2 numbers that they give us. 60 divided by 6 is 10. 10 is the unit rate. That's how many bunnies for every 1 kitten. And you can write 1 down here if you want. That's the unit rate. Now, if I ask you this problem and I give you the unit rate, you can figure out the problem on your own pretty quickly. So ignore these numbers. Now use the unit rate. 10 bunnies for every 1 kitten. If there's 10 bunnies for every 1 kitten, how many bunnies would be present for 8 kittens? Well, if there's 10 bunnies for 1 kitten and you have 8 kittens, obviously you just multiply 10 times 8 and you get 80 bunnies. Whoops. 80 bunnies. So if you got 80, good job. So again, these are 2-step problems. You have to find the unit rate first by dividing the 2 numbers that they give you. And then you use that unit rate to solve the problem. Again, there are 10 bunnies for 1 kitten. That means 20 bunnies for 2 kittens, 30 bunnies for 3 kittens, and you keep going. You're just adding 10 plus 10 plus 10. Or if you want a more high-powered version of addition, you multiply 10 times 8 to get 80 bunnies. That's the fast way to do it. All right, so on to number 48. Let's do one more together, and then you can try one on your own. If there are 42 horses for every 7 donkeys, how many donkeys are there for every 18 horses? So again, we need this is a rate. 42 horses for 7 donkeys. But it's not the unit rate. To find the unit rate, we have to take 42 and divide by 7. And we get 6 horses for every 1 donkey. So now that we have the unit rate, we can find the solution to this problem much easier than if we use the previous numbers. So there's 6 horses for every 1 donkey, and you have 18 horses. It's not hard to figure that out. So see if you can figure that out on your own. 6 horses for 1 donkey. You have 18 horses. How many donkeys do you have? Right, we're in this problem. We have 6 horses for 1 donkey, but you want 18, so you have to add 6 plus 6 plus 6 3 times to get 18, which means there must be 3 donkeys. So this problem was actually a division problem. We had to do 18 divided by 6 to get 3 donkeys. So if you got 3 donkeys, good job. All right, now why don't you try one on your own, and when you come back, we'll do it together. All right, we're back. If a hiker travels 32 miles in 4 days, how many miles will he travel in 5 days? You take 32 divided by 4, just like we did in the previous problem, and that gives you the unit rate, 8 miles for every 1 day. Now that you have the unit rate, it should be pretty easy to solve. If we know we travel 8 miles in 1 day, and they want to know how many miles you travel in 5 days, they just take 5 times 8 is 40 miles. All right, so if you got the right answer, good job. Just be aware that sometimes you'll multiply and sometimes you'll divide in the second step. Try number 50, and when you come back, we'll do it together. All right, we're back. So take 48 and divide by 6, and you get $8 per ounce, or for every 1 ounce. Ounce is abbreviated OZ. How many ounces of precious metal could you buy with $40? So $8 buys 1 ounce. You have $40. So in this case, you're going to divide 40 by 8. In other words, you're going to try to see how many times 8 goes into 40, because you want to know how many ounces you can buy. $8 it costs $8 for 1 ounce. But you have a lot more than $8, so you can afford more than 1 ounce. You just have to figure out how many ounces. So how many times does 8 go into 40? It goes 5 times, so that means you can buy 5 ounces. Or you can abbreviate it with an OZ. So if you got 5 ounces, good job. All right, now in the next problem, it gets a little tricky, because I switched the numbers around. I put 9 first, then I put 63. So don't get tricked by that. In the previous problems, I always wrote the first number, and then I divided by the second number. But that would give you a fraction. You can do that, but it wouldn't make much sense, and it would give you a fraction. So when you're looking for, well, maybe we should read the problem first. 9 toy airplanes cost $63. How many planes could you buy with $28? So if you want to buy 9 airplanes, 9 toy airplanes, the total for 9 toy airplanes is $63. So how many planes could you buy with $28? Well, first we have to figure out how much it costs for 1 plane. So you don't do 9 divided by 63, you do 63 divided by 9 to find the unit rate, and that gives you $7 for every 1 plane. So now we know it's $7 for each plane, for every 1 plane. And just so you know, you don't have to write the 1. It's traditional not to write the 1. Usually you would just write $7 per plane, or /plane. So $7 for 1 plane, and you have $28. So just think about this. Think about the logic. Are you going to multiply 28 and 7, or are you going to divide 28 and 7? Well, if you multiply 28 and 7, then you get 140 plus 56 is I think it's 196, if I did that correctly. So that would mean you can buy 196 planes with $28. That doesn't make much sense. So obviously you're going to divide them. 28. Remember, when you're doing these word problems, you want to use every trick that you have in the book, even when it comes to common sense. In fact, common sense should always be the most important trick that you use when doing any word problem. So how many planes could you buy with $28? You take 28 and divide by 7, because you want to see how many times 7 goes into 28. How many $7 planes can you buy? And you can buy 28 divided by 7 is 4 planes. All right, so why don't you try number 52? When you come back, we'll do it together. All right, we're back. So take those two numbers and divide them. And you get 20 chocolates per box. And you can write the word per also instead of a slash. I'm just doing it multiple ways so you can see that it all means the same thing. So there are 20 chocolates per box. So we found the unit rate first. That was step 1. Now we use the unit rate to solve step 2 of the problem, and that is to figure out how many chocolates are in 3 boxes. So we're going to multiply 20 times 3, and we get 60 chocolates in 3 boxes. 60 chocolates in 3 boxes. So if you got 60 chocolates, good job. All right, so if rates were that easy, then we'd be done. But the problem is sometimes your unit rates are going to be decimals and sometimes your unit rates are going to be fractions. Remember, this course is pretty easy until you get to the fraction part of the course, and that's where things go off the rails. That's the way it is for everybody in the world. When you get to fractions, the calculations are not, and the concepts are not quite so simple. So that's what we're going to do now. If 4 pieces of candy cost $3, how much would it cost to buy 7 pieces of candy? So it's the same procedure. Obviously, we can see that this is not an easy problem to answer here. So we take the numbers, the first 2 numbers they give us, we find the unit rate, and then we use that unit rate to solve the problem. So it's a 2-step problem. So we take 3 divided by 4. We don't do 4 divided by 3. Because if you do 4 divided by 3, you get the number of pieces per dollar. You don't want that. You want the cost per piece, the amount of money that you have to pay for each piece. So remember, you gotta get the order right on these. So we're gonna do 3 divided by 4, not 4 divided by 3. Now you can actually write 3 divided by 4 as a decimal, or you can write it as a fraction. To write it as a decimal, we just use long division. But if you want to write it as a fraction, that's even easier. Writing as a fraction would just give you 3 over 4. So we haven't talked about this much. We're going to go over this more in the next class. But 3 divided by 4 is just interpreted as the fraction 3 over 4. I know that sounds weird, but remember, when we were taking a fraction and we were changing it to a decimal, we would just divide the numerator by the denominator. So now, so the fraction sign is interpreted as a division sign. Again, we haven't talked about this much. We mentioned it briefly. But the fraction is, we're going to go over this more. The fraction is interpreted as a decimal, as a division. It's interpreted as division. We're going to go over this more in the next class. So now we're just going in the reverse direction. We know we have to divide 3 by 4 to find the unit rate. So we're just interpreting that division as a fraction. That's just going in the reverse direction. But for the most part, I mean, you can use either way. You can just write it as a fraction, or you can write it as a decimal, which is what we're going to do here. So you can do it either way. You can do it both ways. So let's do it on this particular problem. We'll do it both ways. But let's first start with a decimal. You're probably going to want to stick to decimals for most of these. So let's change the let's write the unit rate in decimal form. So how many times does 4 go into 3? It doesn't go into 3, so we have to add a decimal and a 0. How many times does 4 go into 30? 4 times 7 is 28, and we're going to put the 7 here. We're not going to put it here because the number always goes above the last digit of the number you're dividing into. 4 times 7 is 28, and 30 minus 28 is 2. Then we have a remainder, so we have to bring down a 0. Then we start the whole process over again. How many times does 4 go into 20? Goes in 5 times. 4 times 5 is 20. And then subtract. 20 minus 20 is 0. So again, if you're a little rusty on this long division stuff, remember, long division is cycles, and each cycle has 3 steps. So you start by placing your number. How many times is 4 going to 30? 7 times. And you multiply 4 and 7 to get 28, and then you subtract to get 2. That's one cycle. Then you bring down your next number, and then the entire cycle starts over again. The only difference is now you're trying to see how many times 4 goes into this number as opposed to how many times 4 goes into these numbers. The entire thing starts over. You go 5 times. That's the first step. And then you multiply 5 and 4. That's the second step. And you get 20. That's the third step. And you subtract is the third step. And you get 0, and so on and so forth. So there's 3 steps in each cycle. If you're really, really intimidated by this, then either you didn't do the homework or you're just a little rusty. And it's okay to be a little rusty. But if you're intimidated by this and you want to go back and look at the class where we learned how to do long division, you should probably do that. But we're going to do many more of these problems, so before you go back, you should probably stick with me here, so we can, because you might be able to pick it up just looking at the problems we're doing now. All right, so we just have to know where to put the decimal. And as you can see, when you have a whole number as a divisor, the decimal is always directly one place, or directly to the right of the number in the ones place. The decimal's right there. It's already next to the line, so we don't have to move this decimal over. We just bring it straight up. So 3 divided by 4, written in decimal form, is $0.75 per piece of candy. So each piece of candy costs 75 cents. So now let's do it using a fraction. And again, using a fraction doesn't really make sense in this problem because it's dollars. We always write dollars with either whole numbers or we write it with cents, hundredths of a dollar. We would never say 3/4 of a dollar. But if we use the same method, we would get 3/4 of a dollar per piece of candy. 75 cents is the same thing as 3/4 of a dollar per piece of candy. So as you can see, there are 2 methods to find the unit rate. You can leave it as a fraction or you can write it as a decimal. So now let's go on to the second part of the problem. How much would it cost to buy 7 pieces of candy? So if it's 75 cents for one piece, then you just multiply 75 cents by 7 to get how much it would cost for 7 pieces. So we're multiplying decimals. We don't have to line up the decimals. The decimal in 7 is right here, even though it's invisible. We don't have to line them up. 7 times 5 is 35. Carry the 3. 7 times 7 is 49. 49 plus 3 is 52. Then we count the number of decimals to the right, or number of digits to the right of the decimal in this number. And we count the number of digits to the right of the decimal in this number. And we can see we have 2, 7, and 5, but we have none down here. So that's a total of 2 digits to the right of the decimal. So we always start here and we count over 1, 2, and we have 5.25. So 7 pieces of candy would cost $5.25. But we can also take this 3/4 and we can multiply that by 7. If we do that, we have to write the whole number as over 1. And remember, when you multiply fractions, you just multiply the numerators. 7 times 3 is 21, and 4 times 1 is 4. But as you can see, we get 21 over 4, which is an improper fraction. So you have to change it to a mixed number. How many times is 4 going to 21? It goes 5 times. I'm going to move this over. So the whole point that I'm trying to demonstrate here is you can use either fractions or decimals. I probably prefer to use decimals. But 4 goes into 21 5 times, and there's 1 left over, and you always write the number in the denominator. You just rewrite that number in the denominator. So you can solve the problem with fractions, or you can solve the problem with decimals. But decimals in this case are much better because dollars are always written in either whole numbers, or hundredths of a dollar. This is not hundredths of a dollar, that's fourths of a dollar. So the decimal option was better in this case. So we're reviewing a lot of math here, but we should probably get going because I don't want to run out of time. Let's do another one of these together. If an armadillo, but again, the whole concept here is we're finding the unit rate first, and we use the unit rate to solve the rest of the problem. If an armadillo crawls 5 miles in 2 hours, how many miles will he crawl in 3 4/5 hours? So again, you can use fractions or you can use decimals. But the first step is always divide those two numbers they give us. So 5 divided by 2 will give us the unit rate, the number of miles the armadillo crawls in 1 hour. So 5 divided by 2, we can do that over here. 2 goes into 5 2 times. 2 times 4, or 2 times 2 is 4. 5 minus 4 is 1. We have a remainder, so we have to add a decimal, bring the 0 down. 2 goes into 10 5 times. 2 times 5 is 10. 10 minus 10 is 0. Bring the decimal straight up. You get 2.5. 2.5 miles per hour. That's how fast the armadillo crawls. So now, how many miles will he crawl in 3 4/5 hours? So we can take the 2.5 and multiply it by 3 4/5, but we haven't learned how to do that yet. So in this problem, let's try using fractions instead of decimals. So let's write 5 divided by 2 as a fraction. We'll just write it as 5 over 2. So 5/2 miles per hour. 5/2 is the same thing as 2.5. We're just writing as a fraction. So that's how many miles per hour, and it says the armadillo crawls for 3 4/5 hours. So in order to figure out what to do here, you can use the factor label method, or you can just consider these numbers to be, let's say that this is 10 hours. Let's say if that's 10 hours. Let's say that this number here, let's make a simpler number. Let's say that that's 5 miles per hour. So if he's moving for 10 hours at 5 miles per hour, do we multiply these two numbers or do we divide these two numbers? 5 miles per hour, and he's crawling for 10 hours. So what is the answer? He's crawling 5 miles for every 1 hour, and he's crawling for 10 hours. What's the answer? Well, obviously it's 50. But we didn't get 50 by dividing 10 by 5. We got 50 by multiplying 10 and 5. So we have to multiply the two numbers. The whole reason that we simplified those numbers is to figure out what operation we use. Do we divide or do we multiply? Again, common sense is your most powerful ally when doing word problems. All right, so we're going to take 3 4/5 and we're going to multiply 5/2. If you recall from your mixed number classes, we have to change those numbers both to improper fractions. This number is already an improper fraction, but we have to change this number to an improper fraction. So in order to do that, we multiply 3 times 5 and then add it to 4. 3 times 5 is 15. And then 15 plus 4 is 19. And then we just keep the denominator. So I know it's been a long time since we worked with mixed numbers. You can go back and review that stuff if you're uncomfortable with it. So we changed 3 and 4 fifths to 19 over 5. We're going to multiply that by 5 halves. So we get 19 times 5 and 5 times 2. Notice I kept them in the factored form, and I can just cancel out those 5s. So then we're left with 19 over 2. And 19 divided by 2, we can write that as a mixed number. How many times does 2 go into 19? It goes 9 times. 2 times 9 is 18. The remainder is 1. Because 19 minus 18 is 1. And you just rewrite the denominator. So our final solution is 9 1/2 miles. So I'm going to write that over here, 9 1/2 miles. And always remember to rectangle your answer. So I know that's a lot of math, that's a lot of review. I could have just did all that stuff without explaining it to you, but I know that you're going to get a little nervous because we haven't gone over this stuff in a couple of weeks. Or maybe we have, I don't really remember. So let's try number 55. So you'll do this one on your own. First find the unit rate by taking 13 and dividing by 4, then using that unit rate to solve the problem. And remember, you can write it as a decimal or you can write it as a fraction. So attempt number 55. When you come back, we'll do it together. If you get stuck here, don't worry, that's okay. We'll do it together eventually. All right, we're back. So we're going to divide 13 by 4. And I'm going to just change that to a decimal. We're kind of running out of time here. So I can't do every single version of this. The best way is probably just to write your answer as a decimal. So 13 divided by 4. 4 goes into 13 3 times. Remainder 1. Bring down a 0. 4 goes into 10. 2 times. 4 times 2 is 8. Remainder 2. Bring down a 0. 4 goes into 25 times. Remainder 0. Bring the decimal straight up. So there are 13 pounds of spaghetti for every 4 pounds of macaroni cheese. That's the rate in lowest terms. But the unit rate is 3.25 pounds spaghetti for every 1 pound of macaroni and cheese. That's the unit rate. So now we're going to use the unit rate to solve the problem. So we go on to step 2. If there are 9 pounds of macaroni cheese, how many pounds of spaghetti are there? All right, so we just have to figure out, are we going to multiply or are we going to divide? It's not easy to figure that out. So we can use the factor label method, but that would take too long to explain that. If you want to go back and look at that, you can. Probably the easiest way is just to simplify these numbers. Let's just say that there are, instead of 3.25, let's say that this is 4 pounds of spaghetti. I don't need to write the whole thing out. Let's just say 4 pounds of spaghetti for every 1 pound of macaroni cheese. And let's say that this number 9, let's change this number 9 to 12. Let's say that that's 12 pounds of macaroni cheese. So if there's 4 pounds of spaghetti for every 1 pound of macaroni and cheese, and there's 12 pounds of macaroni and cheese, how many pounds of spaghetti are there? So let me say that again. It's easy to get lost there. There are 4 pounds of spaghetti for every 1 pound of macaroni and cheese. We don't have 1 pound of macaroni and cheese. We have 12 pounds. So what's the answer? You have 4 pounds of spaghetti for every 1 pound of macaroni and cheese. We don't have 1 pound. We have 12 pounds. How many pounds of spaghetti are there? Well, if you said 48, you're right. And we didn't get 48 by dividing those two numbers. We got 48 by multiplying those two numbers. So again, we use simpler numbers to figure out what operation to use. Now we know to multiply. So we're going to take 3.25 and we're going to multiply it by 9. We're multiplying decimals, so we don't have to line up the decimals. 9 times 5 is 45. 9 times 2 is 18. 18 plus 4 is 22. Carry the 2. 9 times 3 is 27. Plus 2 is 29. There's 2 digits to the right of the decimal in this number and no digits to the right of the decimal in this number. So that's a total of 2 digits to the right of the decimal. So we start here and we count over 2 digits, 1, 2, to get 29.25 pounds of spaghetti. So I know these problems are kind of challenging because we're doing a lot of review at the same time that we're doing these problems, but if you're having trouble with this, don't worry, we're going to review before you take the test. And most of the problems I give you are not too bad in the homework, so let's do number 56. Again, you want to take 4 and divide it by 5 to find the unit rate. Then you're going to take that number and use it to solve the problem. So try 56, and when you're done, we'll come back and do it together. All right, we're back. 4 divided by 5. So we're going to use long division. Bring decimal straight up. So we have 0.8 ounces of flour for every 1 teaspoon of sugar. That's the unit rate. Now again, you could just write the unit rate as 4 over 5. That's another option. But we're just gonna use a decimal now. So now we have to know: do we multiply 0.8 by 22, or do we divide 0.8 and 22? And if we do we divide 22 by 0.8, or do we divide 0.8 by 22? So you see there's 3 options. So a 1 out of 3 chance is not very good, it's not favorable for us, so we have to reduce the options. We have to figure out which one it is. Remember, multiplying and dividing decimals and fractions is not hard, but the most difficult part is figuring out what operation you use. So let's use simple numbers. Let's pretend that this number is 11. So let's say it's 11 ounces of flour for every 1 teaspoon. Then it's going to be easy to figure out what operation to use. So there's 11 ounces of flour for every 1 teaspoon, and they tell us that there's 22 ounces of flour. So how many teaspoons of sugar do we use? There's 11 ounces of flour for every 1 teaspoon of sugar, and we have 22 ounces of flour. How many teaspoons of sugar do we use? I'm going to say that one more time if you didn't catch that. There are 11 ounces of flour for every 1 teaspoon of sugar. We have 22 ounces of flour. So which operation do we use to figure this out? This is not giving us the answer. This is just telling us what operation to use. So figure out what the answer is. And if you said the answer is 2 teaspoons, then you were correct. But how do you get 2 teaspoons of sugar? Do you take 22 and 11 and do you multiply them? Well, if you did that, you get a number that's well above 200. So obviously it's not going to be 200 teaspoons. If you divide 11 by 22, you get 1/2. So obviously that's not right. But if you divide 22 by 11, you get 2. That's correct. So we need to take this number, we need to take 22, and divide it by 0.8. So that's a surefire way to figure out what operation to use. So 22, I'm going to write a little bit higher here. So we used all this work to find our unit rate. We're going to use this work to find the final answer. So ignore the decimal. How many times is 8 going to 2? It doesn't go at all. How many times is 8 going to 22? It goes in 2 times. 8 times 2 is 16. 22 minus 16 is 6. And you can do all the borrowing and all that type of stuff if you want to. We have remainders, so we have to add a decimal, bring down a 0. 8 goes into 67 times. 8 times 7 is 56. 60 minus 56 is 4. Bring down a 0. 8 goes in to 45 times. 8 times 5 is 40. 40 minus 40 is 0. Now in this case, our divisor actually does have a decimal. The decimal is not all the way up against this line. Just a second here. The decimal here is not all the way up against. It's not all the way up against this line. So we have to move the decimal one place to get it up against this line, which means we have to move this decimal one place and then bring it straight up. So you can see the answer is 27.5 teaspoons of sugar. And I'm pretty sure that TSP is the abbreviation for teaspoon. If I'm not, who cares? All right, 27.5 teaspoons of sugar. The only people that would care about that is people that cook. I don't cook, so I don't care about what the abbreviation is. It's not that important. So as you can see, these problems are a little bit more difficult. Let's go on to the next problems here. Looks like we have 4 more problems. So again, you find the unit rate by dividing these two numbers. Then you have to figure out whether or not you use multiplication or division in the second step. So why don't you try number 57? And actually, you know what? We should probably do 57 together. I just realized we're going to get a repeating decimal here. So in this problem, we actually have to use a fraction. And here's why. You take 8 and you divide it by 9. 8 doesn't go into 9, so you have to add a 0. 9 times 8 is 72. Subtract, you get 8. Bring down a 0. 9 into 80 goes 8 times is 72. And you can see you're just going to keep getting 8, 8, 8, 8, 8, 8, 8, 8. So if you divide 8 by 9, you get 0.8 bar. And that would be feet per pound of asphalt. But the problem is we can't really work with repeating decimals. We can't do operations with repeating decimals very easily. You haven't learned that yet. And to be honest, most students never learn that. So we can't use the decimal form. So what we're going to have to do is we're going to have to use the fraction form. Instead of converting it to a fraction, we're just going to write 8 divided by 9 as 8 over 9. Again, we haven't gone over this much, but this is your introduction to this type of thing. 8 divided by 9 is just interpreted as 8 over 9. Again, if you're going to convert a fraction to a decimal, you would take 8 over 9, and you would just take the numerator and divide by the denominator. You learned how to do that when we converted fractions to decimals, but now we're going backwards. We're considering 8 divided by 9 as a fraction. We're going in the reverse direction. So what this means, very simply, is the unit rate is 8/9 feet per pound of asphalt. So it's much easier to use a fraction in the sense that you don't have to do a lot of operations. But fractions, unfortunately, are more difficult to work with than decimals. So now we have to use that unit rate. That's how many feet for every 1 pound of asphalt. We have to use that unit rate to solve the rest of the problem. So the rest of the problem, it says, how much asphalt would the company need to make 10 feet of road? So we're either going to multiply 8/9 by 10 or we're going to divide 8/9 in 10. We have to figure out which way to do it. But it's difficult to see what to do because we have a whole number and we have a fraction. So the easiest way to do this is to just, we already have a whole number, 10 feet. I don't need to rewrite that number, I guess. We already have the 10 feet. Let's change this number to an easier number. Let's change this number to 2. Let's consider 8/9 to be 2. So that'll be 2 feet per pound of asphalt. So now, if you can lay down 2 feet of road, 2 feet of road for every 1 pound of asphalt, then how many pounds of asphalt would you need to lay down 10 feet of road? Again, it's 2 feet of asphalt for every 1 pound, 2 feet of road for every 1 pound of asphalt. And you want to lay down 10 feet of road, so how many pounds of asphalt would you need? Well, if you said 5 pounds, you were correct. Again, it's just common sense. 10 feet of road, and there are 2 feet of road for every 1 pound of asphalt. So if you're on a construction site somewhere, it's not going to be very difficult for you to figure this out. So it's 5 pounds of asphalt. So the big question is, how did you get 5 pounds? Did you multiply 2 and 10? No, because that would give you 20. Did you divide 2 by 10? No, that would give you 1/5. We didn't get 1/5, we got 5. So if you divide 10 by 2, then you get 5. So we know we have to take this number and divide it by this number. So 10 divided by 2. So that means we can erase all this stuff now. We know to take 10 and divide it by 8/9. Again, we can't write this number as a repeating decimal because the operations would be too difficult. So now we have a whole number and a fraction. Whenever you divide or multiply whole numbers with fractions, you have to write the whole number as over 1. You have to turn it into a fraction. And then remember, to divide fractions, you do 2 things. You change the division sign to a multiplication sign, and then you flip the divisor. Then it becomes a multiplication problem. When you multiply fractions, you multiply the numerators. 10 times 9 is 90. And you multiply the denominator. 1 times 8 is 8. And now we just have to change that improper fraction to a mixed number. Now again, I know we're reviewing a lot of stuff here. But this is just the part of the course where things start to get a little bit difficult. But the good news is there's only a couple more classes after this one. And then you're going to be done with this entire course. But don't get too excited, because after the 2 classes after this one, then you have to take an exam. We have to do review. We have to do an exam. Then you have to do a review for the final, and the final. Then you'll be done. All right, so 90 over 8. How do we change this to a mixed number? So you figure out how many times 8 goes into 90. And it goes, it goes 11 times, because 8 times 11 is 88. So 11 is your whole number. And 8 times 11 is 88. You subtract 88 from 90, and you get 2. That's our remainder. And then you just rewrite the denominator. Unfortunately, we have one more step. 2 8s can be reduced. If you divide both those numbers by 2, you get 1/4. So 11 and 1/4 is our final answer. That's how many pounds of asphalt we would need to lay down 10 feet of road. I'm going to move this over a little bit. Whoops. This is really unorganized, really disorganized here. I'm kind of running out of time, so I'm kind of in a hurry here. I guess that's good enough. If you don't have enough room, you can always write division lines. It'll help us organize our work. That's a good thing to do. All right, so number 58. If a toy rocket can fly 2 miles on 3 ounces of fuel, how far could the rocket fly on 8 ounces of fuel? Now this is another example where you're going to have to use a fraction. If you divide 2 by 3 and try to change it to a decimal, or find the unit rate as a decimal, then you're going to get a repeating decimal. So you're going to have to write it in fraction form. So why don't you attempt this problem, and when you come back, we'll do it together. If you get stuck, that's okay. You can just do it with me. All right, we're back. So again, we're going to write this in fraction form. 2 divided by 3 is the same thing as 2 over 3, 2/3. So the unit rate is 2/3 miles for every 1 ounce of fuel. So now we have to figure out if we're going to take this number and multiply it into 8, or if we're going to divide the two numbers. So now let's use that method. Let's say that this is 4 miles for every 1 ounce. So we're getting rid of that number for now. So we have 8 ounces of fuel, and we can go 4 miles on 1 ounce. So if we can go 4 miles on 1 ounce of fuel, and we have 8 ounces of fuel, how many miles can we fly the rocket? Well, if you got 32, you're right. 32 miles. But here's the big question: Did you multiply 8 and 4? Did you divide 8 and 4? Well, obviously, you multiplied 8 and 4. So that tells us, all that stuff that we just did there tells us we multiply these two numbers. So 8 times 2/3, and just to remind you, it doesn't, with multiplication, the order doesn't matter, so you can do 2/3 times 8 also. You get the same answer. That's not true for division. And we're going to write this as 8 over 1. And now we just multiply these two fractions. 8 times 2 is 16. 3 times 1 is 3. Then we just have to change that improper fraction into a mixed number. And just to remind you, it's improper because the numerator is bigger than the denominator. So 3 goes into 16 5 times. 3 times 5 is 15. 16 minus 15 is 1. That's the remainder. And you just rewrite the denominator. So our final answer is, what are we looking for? We're looking for how far the rocket could fly. And our unit is miles. So 5 1/3 miles is the final answer. All right. So for number 59, we have the same situation. If you try to change the unit rate to a decimal by dividing 17 by 6, you're going to get a repeating decimal. So we have to use the fractions. So go ahead and attempt 59. I know these are challenge problems, but it's really just the same thing over and over again. We're just taking this number divided by this number, and then we have to use that number to figure out if we're going to multiply or divide into 4. But you're going to have to write this in fraction form. So attempt 59, and when you come back, we'll do it together. All right, we're back. So 17 divided by 6, we're just going to write that as 17 over 6. Or we could write it as 2 and 5/6, if you want to change it to a mixed number. So it's 17 over 6 miles per hour, or 2 and 5/6 miles per hour. You can write it either way, but when you multiply or divide, you're just going to have to go right back to the 17 over 6, so we can just keep it as 17 over 6. So we found the unit rate, the number of miles for every 1 hour. All right, so now we just have to know if we're going to multiply this number by 4 or divide the two numbers. So let's change this number to an easier number. Let's say that that's 3 miles. Actually, no, that we have to have a number that is some multiple of 4. So let's say 16 miles per hour. So let's use an easier number. Let's say 8 miles per hour. So the deer travels 8 miles in 1 hour. And the deer is moving for 4 hours. So what do you do here? Well, obviously it's just multiplication. So now that we know how to use multiplication, we take the hard number, the 17 over 6, and we multiply that by 4. We just write 4 over 1. And I'm going to go ahead and keep this in factored form, as we did in the previous classes. 6 times 1 we can just write as 6. And now I'm going to factor the 4. So 4 is the same thing as 2 times 2. And 6 is 2 times 3, because I know my multiplication facts. Now we can cancel out 2 of these 2's, and we end up with 17 times 2 over 3. 17 times 2 is 34. So we have 34 over 3. And I know this is a lot of math, but these problems are they're taking a lot of the stuff we learned and combining it. So 3 goes into 34 11 times, because 3 times 11 is 33. The remainder is 1. And you just rewrite the denominator. So our final answer is 11 1/3 miles. That's how far the deer can travel in 4 hours. So if you got that one right, good job. If you didn't, that's okay. These are somewhat challenging because we're using all the stuff that we learned in previous classes. All right. If there are 22 ounces of cobalt for every 6 ounces of sulfur, how many ounces of cobalt would be present with 1 ounce of sulfur? Cobalt and sulfur are just, there are elements on the periodic table. So this is another problem where you're going to have to use fractions. You can't really use decimals. So attempt this problem, and when you're done, we'll come back and do it together. All right, so 22 divided by 6. We can just write that as 22 over 6. And we can reduce that. If you divide both sides by 2, you get 11 over 3. So 11 over 3. And we could change that to a mixed number, but we're just going to have to change it right back to a improper fraction. So let's just keep it as 11 over 3 ounces of cobalt for every 1 ounce of sulfur. 1 ounce of sulfur. All right, so now we have to know, do we take this number and do we multiply it? Oh, actually, I just realized that we're already done because it wants 1 ounce of sulfur. So how many ounces of cobalt would be present for every 1 ounce of sulfur? So in that problem, the unit rate just happened to be the answer. So 1 ounce of sulfur is 11/3 ounces of cobalt. But if you go out and say, I have 11/3 ounces of cobalt, people are going to look at you funny for multiple reasons, but one reason is because you're using an improper fraction. So let's take 11/3 and change it to a mixed number. 3 goes into 11 3 times. 3 times 3 is 9. 11 minus 9 is 2. And just rewrite the denominator. So that's 3 2/3 ounces cobalt. All right. So now let's go to 61. 61, we're definitely going to have to write a fraction because we have 7. It's going to be the denominator. So if we write it as a decimal, it'll be a repeating decimal. It would be very difficult to work with. So try number 61, and when you come back, we'll do it together. All right, we're back. 15 divided by 7. You can write it as 15 over 7. So 15/7 teaspoons of sugar for every 1 piece of cake. And we have to know if we're going to take this number and multiply it into 16 or we're going to divide the two numbers. So let's take this number and make it a much easier number. Let's take that number and make it something that is easy to multiply or go into 16. So let's make that 4. 4 teaspoons sugar for every 1 piece of cake. So if there's 4 teaspoons of sugar for every 1 piece of cake, and it says we have 16 teaspoons of sugar, how many pieces of cake could we make? Again, there's 4 teaspoons of sugar for every 1 piece of cake. And we don't have 4 teaspoons of sugar, we have 16 teaspoons. So how many pieces of cake? Well, if you said 4 pieces of cake, you were right. And the big question is, how do we get that number? Do we multiply 16 and 4? Obviously not. That would give us a number that's way too big. Do we divide 4 by 16? Nope, because that would give us 1/4. But if we take 16 and divide by 4, we get 4. So what that tells us is you're going to take this number and divide by this number. 16 divided by 15/7. We're going to write 16 over 1. And when you're dividing, remember, you change the division sign to multiplication and flip the divisor. Then you multiply straight across when you multiply fractions, because it just becomes a multiplication problem. 7 times 16. Well, let's do 15 times 1 is 15. That's the easy part. 7 times 16, you can do it up here if you want, or you can do it in your head. That'll be 112. So this is kind of a difficult problem here. How many times is 15 going 112? It goes 1, 2, it goes a lot of times. You can try 15 times 4, you can try 15 times 5, 15 times 7, just try a bunch of numbers. I'm going to try 1, 2, 3, 4, 5, 6, 7. I'm going to try 7 times. I think it's going to be 7. 7 times 15 is 105. 112 minus 105 is 7. I'm sorry I'm doing these calculations quickly, but we're almost out of time here. So we have 7 and 7/15. What are we looking for? 7 and 7/15 pieces of cake. And that's our answer. All right. So we have one more problem here. Let's keep our divider here. If a bird flies 11 kilometers in 16 minutes, how many kilometers would it fly in 7 minutes? So go ahead and attempt this problem. When you're done, we'll come back and do it together. All right. So we take 11 and divide by 16. And in this case, I think we can use a decimal. So 11 divided by 16. We can just use long division. I guess I can keep that. 16 doesn't go into 11, but if you add a 0, 16 does go into 110. 16 times 5 would be 80. 16 times 6 would be 96. And I think that's going to be it. 16 times 6. Notice the 6 goes above the last digit of the number that we divided into. Don't put it over the other numbers. 6 times 16 is 96. Notice that I lined up these numbers properly in the right place values and places. 110 minus 96 is 14. The remainder is smaller than the divisor, so that's a good sign. Then we're going to bring down a 0. 16 goes into 140, I believe about 8 times. Again, you can do this multiplication on the side if you want. 8 times 16 is 80 plus 48 is 128. That looks right. Remainder is 12. Remainder is smaller than the divisor, so that's good. Bring down a 0. (16 into 120). 16 times 7 goes in. 70 plus 42 is 112. 120 minus 12 is 8. Bring down a 0. And I think it goes in 5 times. 16 times 5 is 80. And finally, our remainder is 0. So now we can bring the decimal straight up. As you can see, we have 0.6875 kilometers per minute. That's the unit rate. So we want to know how many kilometers it would fly in 7 minutes. So if you pretend that this number is a simpler number, like 2, for example, let's say that were 2 kilometers per minute. It wants to know how far it'll fly in 7 minutes. 2 kilometers in 1 minute, it'll fly, or how far will it fly in 7 minutes? So obviously you just multiply. So now we take that number, 0.6875, and we multiply by 7. Notice that the decimals are not lined up. 7 times 5 is 35, carry the 3. 7 times 7 is 49, plus 3 is 52, carry the 5. 7 times 8 is 56, plus 5 is 61. 7 times 6 is 42, plus 6 is 48. And there are 1, 2, 3, 4 digits to the right of the decimal, and no digits to the right of the decimal here. So that's a total of 4 digits to the right of the decimal. So we count 1, 2, 3, 4. And our answer is 4.8125 kilometers. So we reviewed a lot of fractions, decimals, mixed numbers, all types of operations that we learned previously for those unit rate problems. But the most important thing to understand is to find the unit rate, you just take the two numbers and you divide them in the correct order. And then you use that number to solve the rest of the problem. So unit rate is how many things for every, how many of one thing for every one of the other thing. So the second number in a unit rate always has to be 1. Instead of 2, it would be 1. Instead of 4, it would be 1, so on and so forth. All right, so here's the homework. You can take a screenshot of that if you want. If you want to get 2 pages, you can take a screenshot of that. Screenshot of that. Do the homework completely and correctly. Check all your answers, and if you get an answer, an answer wrong, do it over until you get it right. And I'll look forward to seeing you in the next class.